Well, hi everyone. Thanks for taking the time to take a look at our presentation. I have my team here, Elena and Alexander, to talk to you a little bit about some of our projects and how they take a focus on sustainability to ensure the longevity of the project. So first, a little bit about our team. So we're the Laboratory for Energy and Power Solutions over at the Arizona State University Polytechnic campus. Our team really takes a holistic look to our energy problems that we focus on from both the technical and business side of it, as well as some social considerations and environmental considerations. And all of our topic areas fall into four main categories. So we focus on grid modernization, which thinks about, okay, how can we take technology and integrate it into our grid in order to optimize our operations and integrate distributed energy resources such as renewables. We also consider off-grid systems. So how can we provide power to the 2 billion people in the world that don't have access? Resilient infrastructure considers how power works together with other infrastructure such as roads and water and how they're dependent on each other. And then workforce development is our last topic area, and we consider within that how we can create a strong workforce to support this future energy industry that involves microgrids, renewables, and all of the technology in between. So when our team gets a new project, we often take a look at it from multiple perspectives. Like I said before, we take kind of a technical and business look at things. We are an academic institution, so of course we're interested in writing papers and discovering things and doing applied research. But we also know that it's important to consider a more holistic look at the problem, and that a lot of projects in the world have to take a business perspective to them in order to be successful. So understanding the needs of the user, creating business model canvases to ensure that everything is financially viable. Mission model canvases are specific to the defense industry, but they're just as applicable in the defense space. And then we take all of these concepts and we focus on creating innovation in the form of products, processes, and people in collaboration with our partners between those two academic and business spaces. And in the end, we end up creating a solution that is in some format, whether it's a technology, the delivery of some sort of program, a service, training, etc. So what I'd like to do is go ahead and pass it off to Alexander to discuss our first project.
Thank you, Sam. For this project, we're going to talk about a turnkey water, power, and healthcare for humanitarian action system that we developed. In doing this, we had to try to consider the needs of a bunch of different people. In this case, it was refugees, but other people in the same situations are people who have insufficient access to healthcare, power, and water. To that end, we tried to look at how we could make a system that could be put in place, and that turnkey means it gets set down and you can go right away. It automatically works for them, and there's not a lot of extra work for them to do on their end. We looked into the northern Uganda area and found that there were 12,000 people who had limited health care, once again, insufficient access to water and no power whatsoever. So we thought of how can we combine power systems, water systems, and a health key system into one container, one whole package solution. Once we went past that concept, we decided to do some site visit. We decided to plan in advance of what do these people really need by talking to them on the ground. So in September of 2018, 4 people from our team of LEAPS went out there, and we worked with a couple of our partners with Pipeline Worldwide and some other folks in the local area, including Medical Teams International, UNHCR, and the actual Ugandan government, with community leaders inside the refugee camp as well, to figure out what people really needed. So not just give them a marvelous technological solution, but a solution they could use and benefit from. From that, we had a lot of other partners come together. We have funding from Office of Naval Research. We had our own institution, ASU, a Fulton School of Engineering. We had a local company in Uganda, Solar Now, that helped provide us with technology in country and a supply chain to help warranty that technology. And using all of these partners, we decided to we came up with a sustainable design of this container that utilized the entire 40-foot shipping container to include both that power, all of the power and water in one system, and then a separate section just for healthcare. From that point, fabrication began, and was conducted here in Arizona, along with a lot of our project partners, including DIRT, who helped a lot with the architectural side of things. And we were able to do most of the initial install here in Arizona, and then got to ship it across the ocean. Now, from that, we get to some of our challenges. The logistics of this was interesting, to say the least. Having something moving from one point in our country across the sea and get to another country, travel through roads that may or may not be more developed than others, can be an interesting situation, and it can cause some mishaps, as you can see in that first picture there. Also, while working on site, we only had the tools we brought with us. There wasn't a lot of access to a hardware store nearby. So what we brought with us is what we had, and sometimes you had to make adaptations and improvisations on the fly. Also, during the commissioning process, we run into situations where an additional need or an additional load was identified. So, oh, we really would like to power this as well, or that as well. And we had to try to see what we could do and still maintain the initial scope of the problem and include these new requests as best as we could. From that, we actually finished deployment, and the Adaptive Technology Lifeline for Adaptive Sustainability was deployed in the Isla 2 refugee camp in northern Uganda. Here you can see a picture of the full deployed unit with the solar panels on top and the doors closed. And over here to the right, you can see a picture of the energy system that's inside one of those sections that supplies power to the clinic in a sustainable way. And you can see these orange batteries here are from that local partner, Solar Now, that are able to warranty the equipment should something go wrong. That way we don't have to make a trip across the ocean, because that would be a pretty expensive trip to make just to repair a battery. This gave them marvelous access to this. The entire community sees, the clinic sees about 150 patients per day, and so this was a much needed expansion of their capabilities for the area, which included the power and of course included access to water they could come get from the exterior of the container. And it was marvelous to see people just coming over and work with you and really kind of join with the community as we're there on site, making these improvements for them. One of the nice things as far as longevity of the project, we can check in. Right now, I could go online and pull up the actual power output to see how the system's behaving. We can analyze that data to see if everything's performing as expected, and so far it has been. And we have the technicians you can see up there in that top picture that are able to come out there and address any problems should something arise. Now I'm going to turn this over to Elena so she can talk about some of the surveying we did while we were working on commissioning that project.
Thanks, Alexander. Yeah, so exactly as he said, when we learned that we are going to Uganda, we decided we wanted to investigate more into what is energy access in a refugee settlement like, and possibly what other projects can we do related to the energy sector. And what we found was there's very limited information on what energy access is in refugee settlements. So that's what kind of cooking fuels do they use, or what kind of access to electricity do refugees have. What we decided to do is conduct a survey of businesses, households, and the public services available in a settlement to get a better understanding of what energy access challenges are in a refugee settlement. So the research journey that we took, we started with identifying the problem. So we conducted a literature review to actually understand what do we know before this project about energy access in a refugee settlement. And then we went on to develop the survey. So by better understanding what questions hadn't been asked, we knew what questions we wanted to ask in the survey, and actually created a methodology for collection. Then once we were in Uganda, we conducted that survey. So that included over 200 homes, 20 businesses, and then public services. So in homes, we asked what sort of energy sources they used and what did they use it for. So that could range from charcoal to solar panels. We also wanted to know, do people commonly use renewable energy over other fuel sources, for instance? And then public services as well. Is water more often pumped with solar power or with generators, and so on? And what are areas for improvement? And then finally, once we conducted that survey, we analyzed the results and did a statistical analysis to actually find what's going on. So first, some challenges. So one was survey participation. When you go into refugee settlements, there's many times other people have come before you and asked similar questions or different questions. And then households will be reluctant to answer a survey when they don't feel like they're getting anything back or learning from the survey that has taken place. So what we did is we worked with community engagement representatives, which went ahead and encouraged into, participation. So they explained why we're here. We're also a part of a past energy project and kind of what our goals were. And then we were actually able to establish contacts to later be able to share the results of our survey. The next issue was asking the right questions. So when you get on the ground, sometimes unexpected things arise. So one example of that is that in this refugee settlements, they have grain mills, and they are hooked up normally to diesel generators, and that will be a common expense for households. And that's something we didn't include in the survey because we didn't realize that was going on, that people were grinding grain in these mills. So that's something we missed and had to adapt our survey and our results because of it. On the flip side, you also have to adapt to day-to-day situations. So for instance, there was delays due to the road system or things came up and you had to be able to change your plan and adjust to what was going on. And that's very common in other projects, that you might have a plan laid out, but you'll need to adapt to the changing environment as things come up. So the project found one between the two settlements. The one that lived closer to a wooded area had much better access to wood fuel. So what that meant is that households were spending significantly less money on charcoal and buying wood, which had an impact on their overall monthly expenditures and income. Second, we found water pumping stations were very critical, and those were serviced by diesel generators. And diesel generators in the area have, their supply lines are sometimes not very good. So this was an issue since water is critical and actually having the water pumping stations. Similar to healthcare centers, they had a similar issue, and that's why we did this project with solar and battery. And then finally, we learned that Uganda's self-reliance policy for refugees could be improved in that the 30 by 30 meter plot of land that should be able to provide for a family is really not enough right now. So there's more tools and resources that need to be given to households to actually be able to be self-reliant. So with that, I'm going to transition over to another project. So this one is on the rapid analysis of maps to mini-grids. So for this project, what we found is that microgrid analysis, so when a microgrid project is chosen in large areas, so take the country of Nigeria, you look at a region, you have to decide where are we going to implement mini-grids for rural electrification, for instance. Right now, these processes of analyzing sites is very costly and takes a lot of time. So what we found is through our existing methodologies and methodologies that can be developed, we can reduce time by 90% and reduce cost by 60 to 80%. So what this means is you're changing a process that previously took months down to weeks. So how we do that, and you can see on the bottom of the screen, is we use remote data instead of in-person surveying data that might typically be used. And then we take that and we actually do a power engineering assessment. So we do a high-level engineering, power engineering assessment to understand what are the technical needs of a mini-grid project. And then we use those, by knowing the technical metrics of the project, we're able to create a more accurate business model. So not only is this process both cheaper and faster, but it can actually produce more accurate results because we're doing the extra step of power engineering, which in past cases weren't necessarily included. So as I said, this can be for rural electrification humanitarian needs, but also has applications in the defense spaces for rapid techniques to evaluate adaptive basing opportunities. So what we've done so far in our research journey is we've conducted 2 case study projects where we are able to hone in pieces of this tool. So this is an ongoing project. The first one was in Niger. So we looked into developing a data translation tool where you can actually take the GIS information and transfer it into power engineering software systems. And we did that with PowerGen, who was funded by USAID to do an electrification initiative in Niger. And then the second case study is in Sierra Leone. This is also with PowerGen, but at this point we decided to collaborate with youth mappers. So for this, PowerGen was tasked to identify 45 communities in Sierra Leone in which to establish mini-grids. And we use this as an opportunity to strengthen our primary data collection methodologies. So Youth Mappers actually has volunteer bases worldwide, which maps road systems, buildings, and so on, which is very important to this process. So some challenges that we've come across. First, there's the novelty of the tool. So inherently, when you're doing something new, you're going to possibly come across more troubleshooting, more errors, and that you'll have to work through. So that's our first issue. The second one is unity between the process step. So that means we have I had the 3 high-level steps that I showed on that first slide. So actually bringing it all into one interface so that the final product is very user-friendly, that's a challenge for us. And then next, getting the proper feedback from potential users. So like Sam mentioned in the beginning of our presentation, to have a sustainable project and a sustainable product in this point, or for this example, you need to work with your end users to understand, have you developed it in a way that makes most sense to them? So actually being able to get the correct industry professionals or policymakers who might use this and get feedback has been a challenge, since we need to create those connections and establish that. So our results from that, so from those 2 case studies, we're actually able to create this partnership for primary data collection. So that was on the Sierra Leone side, and organize a way to collect data through them and bring that to our power engineering process. And then the second step, which we did through Niger, was actually reduce by 80% the time it took to translate data from QGIS to Zindi, which we use in power engineering. And that's the flow chart that you can see on the right there. And with that, I'm going to hand it off to Sam to talk about energy education.
Awesome, thank you. So this project is also an ongoing project, one that we've been working on for quite a while now. But what we've noticed is that with this increase in interest in microgrids and modernization of the electric grid, adding in renewables, adding in all of these complex pieces, is that there is an aging workforce that is not ready to take on the challenges of this field. So we decided to develop a solution in that we're creating different training programs to be able to provide that information to them. An additional part of this challenge, though, is that these are working professionals, and so not all of them have the ability to sit in classroom and learn the content. So we're trying to provide flexible training for their need to meet those needs, and then also to keep it flexible for all different types of users, whether that be K through 12 education or college student education or beyond that. And I will kind of outline what that flexibility looks like over the next few slides. So as far as our research journey goes, our team started out as kind of a volunteer effort to create this 1-week training program that I have outlined here. We would really cover everything about microgrids and energy systems, from the basics of what is it and how does it integrate with existing infrastructure, all the way through how do we design it from a high level, how do we integrate components together, so actually getting your hands on some wrenches in our microgrid test bed, and then kind of a detailed power system analysis. How do you make sure that it's going to function in the event of different types of instability? And then on the last day, we took them on some larger scale tours of larger facilities so that they could see all of the infrastructure for themselves. And this was a really fun program. This program's actually ongoing. We still do offer this, but what we found is that not every user enjoyed every single day of this series. They were interested in very particular pieces having to do with their background. If they were a manager, they were interested in certain days. If they were a technician, they were interested in certain days. So what we decided to do was kind of break everything down into modularized topic areas and then make the content within those topic areas very flexible to what we call delivery vectors, meaning you can take the same content and teach it in classroom, you could teach it online in a self-paced format, you could teach it through Skype or through Zoom, and it's all very flexible because the activities that you're doing can be replicated in any scenario. So you can see kind of some of the topic areas listed there. There's stuff for managers. We kind of suggest, okay, maybe you're interested in sort of the high level idea of microgrids and how they're designed, but you're more interested in the business model development than you would be in the technical pieces. Or if you're a technician, of course, you're very interested in deploying units and operating units and maintaining them, but you might not be as interested in the detailed power engineering design of it. So you can kind of see how those are laid out there based on job category. And of course, each of these topic areas can be broken down into many different subtopics that we offer in kind of a modularized or customized way. Some of the challenges for this project, it was really interesting to discover that a lot of the participants in our training had knowledge gaps in areas that were not consistent with others in the group. So each group had different needs. We had a mixed bag of groups, so people, it was a mix of managers or a mix of college students and people in one place, which provided this really great nexus for people to talk and to exchange ideas, but it wasn't always easy on the instructors because the instructors would have to be flexible to provide detailed content or less detailed content depending on the needs. We kind of mitigated that by modularizing and letting people know ahead of time that something is going to be more technical or not. We also had trouble at first deciding what content could be generic. So a lot of the tools that power systems engineers use or managers use really are a very specific software or a very specific piece of hardware. So when you create generic content, you have to find the topics that are a collection in all of those different areas. So we had to choose, okay, can this be generic or do we have to create tailored content for specific software or specific hardware? And determining which content we could do that with was pretty tricky. And then of course scale. So when we learned that there was a lot of interest in this, we wanted to be able to make our sustainable project scalable. So we had to find ways to reach a larger audience than our single or multiple instructors could handle at once. And I'll kind of describe how that worked in the next slide here. So we've trained over 200 people over the last few years in person and in on-site training. So that included the Microgrid Bootcamp, which was that 1-week training program I mentioned before. We have multiple workshops that are 2 to 3 days and more customizable to different training topics. We have some classes at ASU, and then we also go on-site and train people. And how we're able to reach folks in a more scalable way is through these learning tools that we've created. So on the right there, the third picture down, you can see the microgrid on a desk, which is a small scale microgrid system we use to teach concepts to originally K through 12 students, but also now everybody likes to play games. So it's kind of set up like a game. So that same tool also works for adults. We have the mobile microgrid training platform, which is at the top there. It's a trailerized microgrid system that people can learn and build on. And then we have the mobile training toolkit, which is the second picture there, kind of an in-between scale system that has solar batteries, inverter pieces, and they can learn on that. Another way that we found to scale that really worked well is online training. So we were able to take our wonderful subject matter experts and put them in front of a camera and have them provide presentations on topics. So you can see an example right there. But then we can also combine those slides, those PowerPoints and lectures with interactive learning objects that let people kind of play and learn with the concepts right on their screen. And then of course we also always assess our courses for effectiveness. And we're also able to provide links and resources that are available elsewhere on the internet, which really kind of expands knowledge and lets people ask important questions. So with that, I wanted to conclude with some thoughts here kind of from all of our different projects. Something that you'll see in common amongst all of the projects is this needs-based design concept. We really focus on the user and what the user really needs before you really even put your pencil to paper. You got to understand what you're trying to do and how it's going to benefit a certain audience. It's also really important to consider the life cycle of each part of your project. So projects have a lot of different aspects to them. There's technical, financial, social, environmental considerations that you think about when you're creating something, and making sure that the end of life of each of those components can be completed in a sustainable way. Local partnerships are a big part of taking care of a project long term. So fostering community acceptance of something, whether it's a physical system or a process, like Elena was mentioning earlier, really having them feel ownership over that specific product or process, and then they will on their own be able to create around that innovation. And then, of course, be on the lookout for ways to scale and expand your mechanisms through those partnerships or through your own passion and drive for your project. With that, thank you so much for taking the time to listen to us today. If you're interested in more information about our projects, you can contact any of us at the email addresses shown there, or you're welcome to visit our website at leaps.asu.edu. Thanks so much.